In this video, we're going to compare and contrast the E1 and E2 reactions. First, let's quickly look at the differences between substitution and elimination. In a substitution reaction, as shown on the top here, a nucleophile replaces the leaving group. So in the product, you can see that the nucleophile has taken the place of the leaving group, and the leaving group has fallen off. However, in an elimination reaction, we have a base instead, and the base is going to pull off a hydrogen, form a double bond, and kick out a leaving group. So the reactions look very similar at the beginning, but the products are a bit different. This can be a little bit confusing because some nucleophiles also act as bases. Keep in mind that in both of these situations, we need a leaving group that is a weak base. The key difference in the bottom here is that we need this hydrogen here. That hydrogen is referred to as a beta hydrogen because it is on the beta position, alpha, beta. So we can't have an elimination reaction happen if that hydrogen's not there. Okay, now let's look at the two different types of elimination reactions. The one that we've already seen before is the E2 reaction. In this reaction, the base is going to come over and pull off that hydrogen. At the same time that happens, the carbon-hydrogen bond breaks, and those electrons come down to form the double bond over here. As that happens, the carbon-leaving group bond breaks, and those electrons go on to the leaving group, giving the leaving group an extra lone pair. In the example here, the leaving group is negatively charged. In the E1 reaction, the mechanism is a little bit different. You might have guessed by the name that the E1 reaction is unimolecular. The E2 reaction is bimolecular. That means that the E2 reaction has two things involved in the first step, the substrate and the base. In the first step of the E1 reaction, however, we only have one thing involved, the substrate. So in step 1, the carbon-leaving group bond breaks, and those electrons become a lone pair on that leaving group. This gives us a carbocation intermediate. In the second step, the base comes in, pulls off a hydrogen, and the carbon-hydrogen electrons come in and form the double bond. This gives us the alkene shown here on the right, and it also gives us the hydrogen bonded to the base. Let's take a look at this animation of the E1 reaction to get a better idea of how this occurs. In this animation for the E1 elimination reaction, you can see the substrate over here. In step 1, the leaving group falls off, as represented by this arrow here. So let's go ahead and take a look at that. So the leaving group fell off, and now we have the carbocation intermediate. In step 2, you can see the water is acting as the base here. The water is going to pull off the hydrogen, and the hydrogen-carbon electrons are going to come down to form the double bond. So this is what the arrows would look like. There's the water, and there's the beta hydrogen. Now let's watch it happen. The water's coming in, pulling off the hydrogen, and forming the double bond. An H3O+ is also formed in this reaction. Now let's take a look at the reaction coordinate diagram for an E1 reaction. As you can see here, we have the reactants over here on the left. Here's the base, and here's the substrate. In the first step, the leaving group here would fall off. Notice that the energy associated with that first step is the highest point on the reaction coordinate diagram. So this is going to be the rate limiting or rate determining step. The intermediates here are represented by this line there, and you can see the carbocation intermediate right there. In the second step, the base comes in, pulls off the hydrogen to form the alkene, and we end up with our products, shown here on the right. In this particular example, the overall reaction is exergonic, meaning that the products are lower in energy than the reactants, and the two-step reaction is represented by the two transition states, or two humps here in our diagram. This concludes this video on E1 and E2 reactions. In the next video, we're going to talk about reaction coordinate diagrams a little bit more and talk about the kinetics of the substitution and elimination reactions.